Hello, biology class. As I'm sure you can tell, I'm not here today. I am up in the Chicago area. I am watching my son graduate from his basic training for the Navy, and I am also up watching him being inducted into the Nuclear Propulsion Division of the Navy. So I will not be in class today. Whoever's helping me out today has read an announcement, so you may have heard some of this, but I just want to repeat it again just so you're really clear what we're doing today. Right now you're in the middle of an ed puzzle, and this video will go on to show you how to use a dichotomous key. At the end of the video there will be a single question, and you're going to answer that single question, and by doing that and letting the video run to the end, the ed puzzle will send a grade to the Schoology system, and then that way I'll know that you watched the entire video. After you get done with this video, then you're going to go on to your skill check. The skill check consists of two parts. The first part is in Illuminate. We worked with Illuminate earlier in the week, so I know you know how to use it. So you want to log into your account and start the test. Now I'll note that these are SOL-style questions, and some of them are practice. So I want you to be aware that you might not know the answer to all of these, so just do the best you can and answer all the 15 questions. Next, you're going to move on to the second part of the skill check, and that's in Schoology. There are no practice questions in Schoology. These are all real questions that you should know the answer to. The Schoology skill check is worth 15 points, so you should be very careful doing that one. Once you've done the ed puzzle, the Illuminate, and the Schoology test, then that's the end of the tasks for the day. And whoever's helping me out by substituting today will let you know what to do after you're done with all of these tasks. So now here's a short little lesson on how to use a dichotomous key. So whether you're along some sort of river, or you're in some forest, or even if you're in your backyard, here's a short video that I shot to show you how to use a dichotomous key. Here we are. We're in my backyard, and I'm just going to show you how difficult the idea of classifying something is. This is just my backyard. All right, now you can see that I do not take very good care of my backyard. I don't make sure that the bushes are trimmed or anything like that, so that kind of makes my backyard a little bit more fun to deal with. So let's look around, and let's just say that we're trying to figure out what's in my backyard. And let's just start with the trees. And so we look around, and these may look like tree leaves, but they're actually just bush leaves. And now here, what do we have here? We've got some sort of like ivy kind of growth. So this is not a tree or a bush. This is more of a parasite type plant. So we come over here. This looks a little bit tree-ish, but it actually isn't. Once again, we're dealing with something more like a bush. So, but we would, one of the things that we would want to do is we'd want to take note of what the leaves look like. All right, so those are very specific kind of leaves. All right, and we'd want to count how many there were. So, I don't know, maybe what I'll do I'll pull one off and we'll count it. Let's pull one off in the middle. Actually, if you can believe it or not, I actually have a shed underneath there, but the ivy and whatever else this is has overgrown it so much. So that's a very parasitic kind of plant. So we're looking for trees, and believe it or not, this is the only tree that I've got right now. Okay, so despite all the growth that you see and all the stuff that looks like it's way high up in the canopy, this is the only tree I've got. And it's not doing real well, and that's probably because I let all the parasites, those being the parasites, not like a bug parasite, but I let all the ivy grow up, and in the ivy, what it's doing, which is kind of interesting, is it's just taking away all the light and all the nutrients from this particular tree. So this is a real tree, and this is a real tree leaf. And you can see it's got all kinds of spots on it. So I don't know what those are, but probably a good bet would be a fungus. All right, so how do we figure out what kind of tree this is? Well, we use these things called dichotomous keys, and that's what I'm going to show you how to do before you go off on your test. So here, let me pull this leaf down. Here's what I've harvested. Okay, we're going to go make sense of this leaf. And I'm going to take the video inside and we're going to get onto a computer. Now with some of these keys that I'm talking about, you'd actually have them with you out in the field, you know, and so you can see once again, got a plant. It's kind of interesting. We will talk about that when we get into plant biology. You've got leaves that look kind of tree-like, but they're not trees. All right, and the way that we would tell that is that we would have a dichotomous key. And I'm going to go inside now and show you how to use a dichotomous key. The computer. Now, like I said, you might be just as likely, you probably, if you're going to be out in the field, you're going to be more than likely to have a paper key. But this is the way a key works, and you can see it's got a key down there. Can you identify your tree? All right, so we've got our leaf. Let me put our leaf up there. So this is the leaf that's of question, right? So we're going to use this, and this is how a dichotomous key works. So let's start working and click on the key. So that's what I'm going to do. I'm going to click on the key here. And was the tree that I had a conifer or was it a broadleaf? Well, it was a broadleaf tree. We will discuss the difference between these once we get to plant biology. So let's see if I can get my mouse up there. There we go. It was a broadleaf tree. Were the leaf compound leaves? By compound leaves, remember that first kind here? Actually, I've got it in my pocket right here. So this is a compound leaf. Okay, this is what they're talking about with a compound leaf. You can see what they're talking about is that there are a lot of attachments to it, right? That is not what we've got. Our leaf is like this one right here. Okay, so that's not a compound leaf. So we've got a simple leaf. All right. Are the leaves on opposite sides? I forgot to note that, but I would say that they were not lined up opposite each other, so I would say they are alternating. All right, is the leaf lobed, or is the leaf not lobed? All right, so let's see what they're looking at there. They're looking at pretty much even jagged edges seem to be okay there, and here we're talking about like real lobes. So this guy, I'm going to call him not lobed. Okay, so let's stick with he's not deeply lobed. Okay. Is the leaf edge smooth or is the leaf edge not smooth? Well, no, the leaf edge is not smooth. So this guy is going to come down into this category. So the leaf edge is not smooth. Okay. Is the leaf thick and leathery? Or is the leaf not thick and leathery? Now, see, thick and leathery usually refers to leaves that are in areas where a lot of sun or they're trying to retain water. This leaf is not that worried about it. This is a regular leafy sort of material. So we're going to come over here. We're going to click this one. All right. Is the leaf leathery? Is the leaf not thick and leathery? Okay. So I would say that this is going to come under the category of not dry, so it's going to be more fleshy. Looks like we've gotten off into the fruit trees. So let's see, let's go backwards a little bit. Let's go ahead and say that the leaf is thick and leathery. There's kind of a sharp spine. Well, they don't really have sharp spines. Let's go there. Does the leaf have pointed teeth? Yes, it does. Okay. So, a tan oak. So that looks pretty reasonable. Looks a lot like the tree that I got. It probably isn't, just to be honest with you, because I am using a dichotomous key from the Pacific Northwest. But really what I did was I just wanted to show you how dichotomous keys work, and so you can follow me through what I've done. So basically I looked at the structure of the leaf, I looked at all the characteristics, I've matched up all the characteristics, and it took me to the point where if I had this leaf and I lived in the Pacific Northwest, I very likely would be looking at a tan oak. That is how a dichotomous tree key works.